fair coins, let's deal with a slightly back. I actually recorded this video earlier today, but I realized my microphone wasn't plugged in, and I won't name names in terms of who unplugged it. But anyway, back to probability. My wife is giggling mischievously. Anyway, so let's do a slightly harder problem than we did before. We were dealing with fair coins. Let's deal with a slightly unfair coin. Let's say I have a coin, and it's actually, instead of unfair coin, let's do basketball. Let's say I'm shooting free throws, and I have a free throw percentage of, free throw percentage is 80%. So when I shoot a free throw 8 out of 10 times, or 80% of the time, I will make it. That also says that 20% of the time, I will miss it. So given that, if I were to take, 5 free throws, what is the probability? What is the probability that I make at least 3 of the 5 free throws? What is the probability? Let's think of it this way. What is the probability of any particular combination of making 3 out of 5? So what do I mean by that? Let me pick a particular combination. Let's say it's a basket, 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 and then I miss. So that would be, I made 3 out of the 5. It could be, basket, miss, basket, miss, basket. And there's a bunch of them, and we'll actually try to figure out how many of them there are. But what is the probability of this particular combination? Well, I have an 80% chance of making this first basket times 80%. That's a times right there. Times 80%. And then what's my probability of missing? Well, that's 20%, right? Times 0.2 times 0.2. So this equals 0.8 to the third power times 0.2 squared. But what's the probability of getting this exact combination? Well, it's 0.8 times, and then I miss. There's a 20% chance of that. So times 0.2 times 0.8 times 0.2 times 0.8, right? We could rearrange this, because when you multiply numbers, it doesn't matter what order you multiply them in. So this is the same thing as 0.8 times 0.8 times 0.8 times 0.2 times 0.2. So this is also the same thing as 0.8 to the third times 0.2 squared. So pretty much the probability of getting any particular combination of 3 baskets and 2 misses is going to be 0.8 to the third times 0.2 squared. Now, what's the total probability of getting 3 out of 5? Well, it's going to be the sum of all of these combinations. I could list them all, but we hopefully now are proficient enough in combinatorics and combinations to figure out how many different ways, if we have 5 baskets and we have 5 shots, and we're picking 3 of them to be the ones that are basket shots. So what do I mean? So let's say my 5 shots. So, I have shot 1, 2, 3, 4, 5. And I'm going to, out of these 5, I'm going to choose 3. So I'm putting my hat on as the god of probability. And I will choose 3 of these shots to be the ones that happen to be the ones that get made. So essentially, out of 5, I am choosing 3. 5 choose 3. And what does that equal to? That's 5 factorial over 3 factorial times 5 minus 3 factorial, so that's 2 factorial. That equals 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1 times 2 times 1. We can ignore all the 1s. Let's see, we get 3 times 2 times 1, 3 times 2 times 1. We can cancel that. This 1 we can ignore, and then this 2, and then this 2. So there are 10 possible combinations. These are 2 of them, basket, 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 miss, miss, basket, miss, basket, miss, basket. And, it's a good exercise for you to list the other 8 of them. But using just our, the binomial coefficient, and hopefully you have an intuition of why that works. And I'd be happy to make more videos if you feel that you need more explanation, but I made a couple. There are 10 combinations. So essentially, the probability of getting exactly 3 out of 5 baskets, if I am an 80% free throw shot, is going to be, switch colors. The probability of 3 out of 5 baskets is going to be equal to the probability of each of the combinations, right? Which is 0.8 to the third, 0.8 to the third times 0.2 squared, right? I make 3, miss 2, and then times the total number of combinations, right? Each of these has a probability of this much, and then there's 10 different arrangements that I could make. There's 10 different ways of getting 3 baskets and 2 misses. So times 10, and what is that equal to? Let me get my high-end calculator here. So let's see what that is. That is 0.8 times 0.8 times 0.8 times 0.2 times 0.2 times 10 equals 20.48. So it's essentially 20.48% chance that I get exactly 3 out of 5 of the baskets. Now let's say let's make it slightly more interesting. Let's say I don't want to know the probability of 3 out of 5, and then this is actually something that probably people are more likely to ask. What is the probability of getting at least 3? At least 3 baskets. Well, if you think about it, this is the probability. This is equal to the probability of getting 3 out of 5 baskets plus the probability of getting exactly 4 out of 5 baskets plus the probability of getting exactly 5 out of 5 baskets, right? Well, we already figured this one out. That's 20.48%. So what's the probability of getting 4 out of 5 baskets? Well, once again, if we want exactly 4 out of 5 baskets? So an example could be, I don't know, basket, 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 basket. What's the probability of any one of the combinations where I make 4 baskets? Well, it's going to be 0.8 to the 4th times and then I have a 20% chance of that 1 miss, right? And then, it could have been basket, miss, basket, 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 right? That's the same. That's also exactly 4. But when you multiply them, the probability of getting any one of these particular combinations is exactly this, 0.8 to the 4th times 0.2. And so how many ways can you, if I have 5 baskets, how many ways can I pick 4 of them to be the ones that I make if I'm once again the god of probability? So this is going to be 0.8 to the 4th times 0.2 times 0.2 times, out of 5 baskets, I'm choosing 4 that I'm going to make. So this is the number of combinations where I get 4 out of the 5. So what does 5 choose for? That's 5 factorial over 4 factorial times 1 factorial. That equals just 5. You can work that out. So it's going to be, so let's just figure this out. So it's going to be 0.8 times 0.8 times 0.8 is 3 times 0.8. That equals, did I do that right? Let's see, 0.1, 8. Yeah, that's right, times 0.2 times 5 times 5. So 40.96%. So this is 40.96%. So roughly 41% chance that I get exactly 4 out of 5 baskets, which is interesting because that's kind of my free throw percentage. So it's almost a little less, 2/3 shot of kind of hitting my free throw percentage on the mark on that time. And that's probably of getting 5 out of 5. Well, there's only one way of getting 5 out of 5. You have to get all 5 of them. So this is 0.8 to the 5th power. Get the calculator back. So it's 0.8 times times 0.8 times 0.8 times 0.8 times 0.8 equals 0.3276. So 32.77% shot. And then we can add them all up, right? Because we want the probability of at least 3. So it's going to be that, the probability of getting 5 out of 5, plus the probability of getting a 4 out of 5, which is the probability of getting 5 out of 5, plus the probability of getting a 4 out of 5, which is 0.4096, plus the probability of getting 3 out of 5. So that's 0.2048 equals 0.94208. So 94.21, roughly rounding, percent chance, which makes sense. If I have an 80% free throw percentage on any one shot, I have a very high probability of getting at least 3 out of 5 when I go to the free throw line. Anyway, I'm all out of time. I'll see you in the next video.